the data set, we are saying that 5,000 plus of them has churn. Sorry, has no churn because zero is no. Then, oh shit, my network is bad.
Uh,
Oh, don't.
I think we should kind of be we should not emphasize much on this visualizations part.
Can you present your screen because me, I'm not seeing anything again. Okay,
Can you see now?
I can see. What's the challenge down here?
You there?
Yes, yes, yes.
Any challenge here, or we should move on?
Now let's move on. This is
Okay.
just visualization.
Yes. So I'm
Let's
even
move on.
thinking here there's no much problem except for this place that you say something. So let's see if I and to have a different view. Then we'll move on. We'll just keep the other part of the visualization. Andrew, are you there?
Yes, this heat map.
This is there's something she said that we are doing correlation. We are trying to correlate the attribute of this data set to a particular future or something. So because me, I know we are trying to check the relationship between each of the attributes in the data set. But to me, I don't know
Yes,
if
so
she still explain more see.
go ahead and explain your way, man. Let's hear what you say.
No, you should talk.
Okay, Andrew,
Go
now
ahead now, you might be.
No, continue.
All right, so like he said it already, so there's nothing much to say again. It's just how one feature relates to another, right? For
Okay.
instance, when you look at streaming TV, compare it, take it vertically, what will be the first column there? It's having
yeah,
0.11. Scroll down, take it downward. Can
to
you
see
see it with
the
senior
relation.
citizen?
It's
So the
okay.
relationship between streaming TV and senior citizen is 0.11. So it's the degree of how one influences another in predicting churn or not churn. And
Okay.
diagonally, you always have one, meaning each column to itself is highly correlated.
Mm-hmm.
Yes,
So if you look at anywhere you see one is 100% correlated, is churn and churn. Look at the next one, total charges and total charges is one.
difference over.
Monthly charges and monthly
My
charges
emotion,
is one. Whenever you have an intersection of same field, you get one. While others determines the degree of correlation between itself and the other class. A negative value in terms of correlation determines that that particular feature to the other feature is not highly correlated. For instance, paperless billing and internet service, can you trace that?
Yes,
Minus
Giving my
0.33.
internet service.
Can you
Okay.
see? So you can
yes,
see that the degree of correlation is a negative. That means it
Negative
does
one.
not really influence the prediction with respect to paperless billing, right? So, being the fact that paperless billing and internet billing is not highly correlated does not mean that it will not correlate with other fields.
yes,
So, scroll down. Here we are just looking at the scattered plot, right, for each of the value. So, we are looking at how between those monthly charges and likewise the total charges, how correlated are them with churn itself.
okay,
You can look at the more painted it is, that means it's highly influential to churn in terms of the monthly charges or total charges. So zero is churn like that, one is not churn, abi, if I could remember. So go down.
yes. Mm.
Zero. So no, that one I commented it as we did not use it. Now look at here we are getting the numerical field, right? And we
Mm.
just describe it. The essence of description is just to get statistical information about it. Then for categorical field also, we get those that are categorical. Categorical in the sense of those field we converted to zero, one, and 2 and zero, one like that. That's the categorical field. And the numerical field is those that have like floating values or continuous values. So we are just aggregating them into separate classes so that we can visualize them. Go down. We can see for tenure the histogram for numerical features, right?
Yes.
So for the first bar, you are saying that, let's say first bar is around minus 0.9 or 0.8. You're now saying from the standardized record, 0.8 of the standardized tenure is up to 1,000 plus. The next one, let's assume the next bar is 0.8. So that means for minus 0.8 with respect to tenure, for the total charges, we have a total charges that closes 700, or sorry, 500 and something, closing to 600. So this explanation spans to others also, all in this particular place.
Okay.
So scroll down. So here, box plots, we are just looking at how influential and churn is and tenure, right? With respect to tenure for the two separate classes. Go down. So you can see for the class of 0 and 1, 0 is highly, you can see the bar is really stable in the middle, while the other class for 1 is not really stable because the record are not the same. If it's at the middle, you now say all of them, they are like almost like if their distribution is equivalent or something. So scroll down. So by this visualization, you should know that we really need to do data augmentation. Same when you apply churn and monthly charges, you can see it for the class of 0 and for the class of 1. When it tilts towards the middle, that particular part is more equivalent, is highly distributed than others.
Yeah, same
Scroll down.
thing.
Like that for this class. That applies to it. Go down. So this churn distribution by senior citizen, right? For senior
Yes.
citizen, we have two classes, which is yes or no, right? So when
Mm-hmm.
you look at tenure, sorry, when you look at churn and 0 and 1, I think 0 is no churn, abi?
Yes.
1 is churn. Good. So if you look at for the class of 0 with respect to the citizen class, right? And the citizen class, we have what? Two distribution, which is 0 and 1 also. For no is citizen class, is a senior citizen class. Yes is not. So for the distribution for the total record, if you look at the class of 0, that is not a senior citizen class, then the total record for churn is around 4,000 plus. Then the total record for not churn was around 1,000 plus. Can you see it for the first bar? But the second bar, when you are looking at rating people, the only classes that is churn and not churn on the class of 1, which is yes, is a senior citizen. You are looking at instances from the record that are senior citizen with respect to whether they are churn or not. Churn means they will leave the organization or not, Abi.
Yeah.
Yeah, they will leave the network.
So they will leave the network or not. So you can see for the senior citizens, about 500 and something is churn. 0 means no churn, but it's not churn. That's
Yes.
the next bar that are down. Then the other part also for 1, you have around 400 and 400 something. I'm just assuming the value because I can't really say at this point.
But me, my,
So you
my
can see
question
the
is, why do we have two bar here and two bar here?
good. That's what I'm explaining. Look at up there, you have the label 0 and 1. Those two bars is churn and not churn.
Yes, for the
Now,
same.
why we have
Hold on, Andrew. You know
yeah.
that we are trying to predict customers that will churn the telecommunication industry
Hmm.
and those that we are trying to find out those that are likely to churn, to leave.
Mm-hmm.
Uh-huh. Now, why we have not done the prediction? Why do we have the churn and the
It's
no
from your
churn?
data set what you have. These are just distribution. Look at that's why it's there. Churn
They
Okay.
were
distribution.
just okay.
Okay, yeah, that one is from the data set because like this data set now, if you look at it, we already have that churn and non-churn here. Look at the churn here. So we already have the yes and no already here. So that is what we are visualizing here now
Okay.
with respect to senior citizen. But now
Okay.
my question I'm asking is
Senior
that
citizen have two class. Go back to your data set.
okay, senior citizen has two class. Because that was a question I was trying to ask you. It has no and yes too, right?
Yes.
Yeah,
Okay,
it has
okay,
also no and yes.
okay.
So you are
No,
not saying for the class of senior citizen, no senior citizen, which is zero, right?
yes,
Zero means they are not senior citizens. We are now
yes.
saying that when you look at churn and not churn with respect to no senior citizen, those that are not senior citizen, you
Mm.
have around 4,000 plus
No,
that.
yeah, I understand that perfectly. Because now,
Okay.
when you take the no and the no from the senior citizen and the no from the chunk class, you have this bar. Then when you take the
Yes.
no from the yes from the senior citizen and the yes from the chunk class, we have this
Yeah.
other bar here.
No, no, not like that. Understand? When you
This
take,
one is
let
for
me,
senior citizen, while this one is for churn.
good man, that's it. Then the two bars at the top is you are now saying that you have, it's just like, look at, let me make a simple analogy for you.
Mm.
In a population, you have male and female.
Yeah.
Yes,
Assume your one class to be male. That is the class of zero. Instead of senior citizen, now I'm replacing it to male and female.
mm.
The class of zero, right? Let's
Yes,
assume to be male. And then the class of female to be one.
mm.
Now, when you divide those two groups in a particular telecommunication industry, you have two sets. Then, from each of the sets, you are looking at those that will churn or not churn.
Yes,
Okay.
That's why you have those two bars at the top of each of them.
yes. I
Do you
understand.
understand it now?
Mm-hmm.
I
Ehen.
understand. Mm.
Good. So go ahead, go ahead.
I think the same
Same
thing is applicable here.
to partner and then to dependent like that. Same thing we are checking. So
All right, so here now.
now this one is same thing, but we are looking at it with respect to internet service and payment method. Then whether it will churn or not. Scroll down. Look at for the class of 0, the first bar.
Mm.
What's the first bar? Go up, you see what the first bar is. Can you see? Zero. Can you see where one stop? That
Yes,
means churn is higher for that
okay.
first bar. Then the second bar, the orange part is the part is just like a shading on top of another shading. The one that is much will be at the top. So you can see from it, we're having high degree of churn.
Okay.
Yes, compared to this other one.
Yeah, when you are looking at each of it with respect to the payment method.
Yes.
Scroll down. Same thing, this is just a distribution. If you
Since this one is like a repetition here, because we'll have this visualization up somewhere.
okay, okay, I repeated it then.
Mm.
So of the churn and retain customer. That's customer that will stay and will not stay is
Yeah,
the same
that
thing.
that will be yeah.
Mm.
Churn means they will leave. The one that will go is churn that will leave. Then the one that will stay is retain customer.
Mm.
Is another way.
This uh, plot here,
Yeah, it's just a snare plot.
okay, to
Each of
visualize.
this one mostly applies to those numerical value
Mm.
for the different classes. And this one with respect to contract type, we have different contract type from the data set. I think contract have three classes. You can go to it and check. It's having three classes. Look at contract. Contract type, is it 1 month?
Okay, we have month to
Have
month.
month to month, 1 year, two
Mm.
year.
So those, yeah, so that's it.
Okay, that's
So
how we converted them to three, zero, one,
the
and two.
one
Yeah.
and so. So for the bars on top of it is based on those monthly stuff, how which is churned and which is not churned, how many is churned and how many is not churned.
Okay. Split.
So after doing our visualization, we want to split it, divide it into training and test set. So we take the S set, which is, go back to our data set. Now, from the beginning to second to the last, right?
Like this.
From the beginning to second to the last.
I should go down there.
No, 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 no. Like in terms of the column,
Okay.
from the beginning to
Uh,
second to the last column is
yes.
the x-axis, which is the independent cell. Now, this is what the independent cell does. It's based on those information from the X that you can be able to know whether a particular record is churn or not churn.
Yes. Yes.
Whatever information was passed from right from the row one
Till
to
this.
the second to the end, we will
Till
now
this one.
determine whether from his total charges, monthly charges, payment method, paperless. So for one record, right? That's for number two itself.
Mm.
Based on those instances, they are the independent cell that determines whether it's no churn or yes churn. Do you understand, man?
Mm-hmm.
The last cell, which is the churn itself, is the y-axis, which is dependent on the x-axis. So,
Okay.
and the
Okay.
y-axis is our churn because
Yes.
that's what we're trying to predict. And you can't just say it's
That's
churn
the
just
dependent. Um,
like that without looking at some attributes and independent.
no, no, no. Why is independent or dependent?
This thing is straight. X, y is dependent.
Okay.
It
Churn is
depends on,
dependent. Yeah, don't worry. Sorry. Whether they churn or they don't churn, a customer is going to churn or not churn is dependent on the other attributes.
Exactly.
yes.
I
Okay,
get
me
it.
correct that thing, please. It's dependent there. Yes.
Yes, I understand. But Andrew, why do we use this word here? Drop. Do you drop these other ones?
Don't worry. It does not. That's why I'm storing it in X. I'm only dropping churn, then I'll store the rest in X.
Okay.
Yeah. Then I'll target the churn in the next place. So it's not like I drop it totally. I'm dropping it, but I did not put in place there. Had it been I put in place there, it will remove it totally from the data frame.
Okay.
So now we want to apply our counts. Now look at, we are using our counter to check the statistics of the number of churn and not churn. You can see. So we are checking before we apply smooth. We have a counter to check for the class of 0, which is no churn, Abi. We have 5,174 records that
Mm.
are that are not churn. Then for the class of 1, which is churn, we have 1,609. 609. 1,800 1,869.
869.
69.
So you can see it's not
Yeah. It's
equally
not balanced.
distributed,
Yeah.
not balanced. So the next line, you don't need to worry about it. I was forcing some installation on my system due to the fact that some of my libraries were old.
Okay.
So you can see now, we want to apply the smooth. Can you see? First, I tested
Mm.
um
What?
smooth, right? Not smooth ENN, right?
Yes.
and I was able to get result. If I remember, I reported it to you, and you were like, "We should try and improve it." Right?
Yes.
I now apply smooth ENN. So you can see the first cell I apply smooth, but because you say we should check another way, I went ahead and tried smooth ENN. That
Okay.
gives us the result that we are currently using. So
Okay.
after applying smart ENN, you are going to pass the X and Y to it. So you fit it with the resample X and Y that you divided. Then you now get new samples of S resampled and Y resampled. Can you see what smooth ENN does? So it brought them, instead of, before, you if you take note, the class of um 0 is higher, which is
Mm-hmm.
5,000 plus. Can you see it?
Yeah.
So you can see what, instead of argumenting the class of 1 here to equal 5,174, what it does now go down is to bring them close to balance, instead of incrementing data, bringing data anyhow. Can you see? So here we now have 3,648 by reducing that other class and balancing this one to come close to it.
Okay. It must not be the same
One.
If I use
100%.
smooth, if I use smooth, it will be the same.
Okay.
Of the algorithm have their own way. And what smooth will do is that, right, each of the class will be 5,170, 5,100.
Okay. 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 To just populate and over sample over
Yeah, it will just bring
sample that
some
one.
random data and argument it. So because I don't want to bring anyhow data that will now bring inconsistency in my data set, I'm now saying that also look at the other set that are merged. See whether you can argument some to suit the class of 0. That's what we are doing there.
All right.
So after doing that, we split the data set into the train. Normally, when you are training a machine learning model, you have to hide some data now, Shay. It's
Hide
just
some.
like normal. It's just like normal school exams now. They will take you a course, then they will now give you exams. They will hide the exam answer from you. So
Mm-hmm.
what we are doing here is to split the data set into training. The X train is for the X, which is the independent value. We are taking. Then we also have the X test, which is for also the independent value that we use for test. Then for the Y train is the part of the answer that will pass to the model during training so that it will know some answers, right? Then the
Mm-hmm.
Y test is the answers that will hit for him just like during the exam so that we'll now use it and
To
validate whether
test
the model is
it.
right.
Okay.
You can see we pass our S resample from our smooth ENN. Then we are now saying that we are taking, look at the test size. From the total of our data sets, we are using 0.2, which is 20% of the data set to
For
test.
test.
Then the random state is just to shuffle the data, right? So that they won't be biased much like that. The stratify there is to ensure that those values from the Y's, they do not, sometimes when you shuffle, you before you know it will shuffle and take other answers of other to other. So why stratify there is to ensure that those value after shuffling, they matches their dependent and independent cells.
Okay.
So next to it, we are going to apply random forest, and then we, after applying random forest, we suit it with the training data. Can you see? Fit the model. So rf underscore model dot fit, we fit it with everything training. Can you see? X train
X
and Y
train
train.
and Y train. Yeah.
Then after we are done training it, you can see predict
Sorry, if
manifest.
I might ask question. You know there are so many algorithms. Why is in random forest the these three that we chose? Why are they the best for this kind of data that we are having?
I was thinking you had the one that proposed it though.
You
No.
said
No.
Okay.
Why I propose this to me is because we are dealing with classification, and this algorithm, based on previous studies that I've looked at, these algorithms are very good for churn predictions. You know what makes our work different is that not as if this algorithm has not been used, but we are trying to check if there's bias. Do you get? So this algorithm that others have used for this same task, and it yielded good result. We are not trying to assess if they have a bias or not. I don't know if this answer your question very well. Why I choose it is because it's good for other based on other research. It has a
Oh,
good
well,
performance.
don't vex me.
It will not
Based,
vex with
no,
you.
no, no. We can't say based on other people's research. We need to look at our data set and study, know the best algorithms for it.
Yes, now that we've no, now that okay, no. The algorithm still is still the best because it's classification. You understand? It's for classification task. See what will happen.
Classification.
Is it me
Um,
that I'm hearing as if your network is breaking? So,
please, do you know what we'll do? Andrew is trying to
No.
join another meeting. So let's finish up. Then we'll now explain this algorithm
Okay.
together.
Okay.
Yeah. Andrew, please continue. Let's finish. How you can go, please. May Edward no verse. You don't remain like few lines now. We'll finish.
all right. So the next thing is predict. To predict, you can you see when you want to predict, it's just like sitting at the exam hall to write. So you can see predict on the
Mm-hmm.
test. We'll give them the questions, which is the S test question that we kept for testing. Then you see here we did not pass the answer to the model, right?
Mm,
RF underscore model is the random forest model. You can see we did not give it the Y underscore test, which is the answer for the test.
okay.
So from there, it will now predict Y predict. Now, Y predict is what he predicted at the end of the exams. From his test, he predicted some answers. So we are going to use his answers to compare with the initial answer on accuracy score. Can you see Y underscore text? We compare it with Y underscore predict, what random forest predicted. And then we now from there it will weigh it, which one is correct, which one did you answer well, and it will give us the result as accuracy. Then furthermore, we apply classification report, right? And
Yes.
also pass the same thing, Y test and also Y predict, so that we evaluate also, not just that we depend on accuracy, we want to look at other classification metrics also. Scroll down. From there, you can see the accuracy is 0.95. On evaluating it on classification report, you can see for the different class. For the class of 0, which is no churn, we have 0.94 and then 0.95 for precision. So for the class of recall, we are saying that this model is good with a degree of 0.90 in terms of recall as a metrics to evaluate it, and in class of um, 1, we have 0.95. Likewise for the F1 score. But one key thing again, the classification metrics also gives you an accuracy score. So you can see the accuracy also confirms with the accuracy that we check using the accuracy metrics at 0.97. Then for the confusion metrics is instances that we have true positive. Um, the
False
first
positive.
cell is true.
Mm,
Then the second cell is that's the second quadrant is false positive. Then we have
you
the
see?
third one is false negative and true negative.
Yes.
So true positive is the number of instances that from the data set it was true and the model predicted it to be true having churn. Then true negative is the instances that is not churn and the model predicted it exactly to be not churn. Then for the other side, which is the diagonal line going towards my right hand side, 36 and 35 is the misclassified instances by the model. You can see, yeah. So for those, false negative means that false negative means the model from the data set, a record is saying true and the model say
Not true.
not, it's not true like that.
Mm,
So the diagonal axis there, 35 and 36, is just misclassification
yes.
for the instances that is having churn and the one that is not having churn but was classified to have churn.
All right. Let's move on.
So future importance is to see how important each future is in terms of prediction with respect to random forest. So
Okay.
scroll down, you can see that The contract is very significant in terms of predicting churn. Then the monthly charges also, the tenure, like that, they goes down as the bars increase. That shows their degree. So if you are taking a threshold of
Sorry. Um, Moving from the left or right, these ones are the ones that are more important, right?
yes,
Contract charges and all this. But you know we have a lot of features. Can we make use of like few, five to predict instead of using everything?
then you not get good results now. You can't just give it small data. It's just
Uh,
like in your school now. You went to school and they just teach you one plus one, they left the rest for you. Do you think you'll be good like that? You need
not at all.
enough information. You need
Okay.
enough information before
Okay.
you now say you are good. So the number of data supplied to you also matters in you learning very well.
Okay.
You can't just carry two instances and give a model to be good when it's giving plenty data. It will be overwhelmed and it will not give you what you want.
Okay.
Yes. I
Yeah,
don't know
yeah,
if
yeah.
that.
We're almost
Yeah.
there.
So here we are just doing hyperparameter tuning using the grids set CV. We're augmenting the random forest algorithm so that it will do more better than that 95. So there's a way random forests work, just like the name implies. It's just a tree algorithm, right? It has number of estimates on how many trees will be on each level, and then the maximum depth, just like the way you do binary search tree,
Yeah.
right?
Mm-hmm.
In data structure. So that's how it behaves. So we are now augmenting this parameter, right? We are we are taking 50 number of estimator, 100, 150 for the max depth. The first time we will not go deeper. Then the second time we go 10 step deeper, 20 step deeper, and see which of the parameter from each of these gives us the best results in predicting. So from there, we now use grid shared CV. We pass the parameter and we pass the estimator. You can see the estimator there is random forest that will pass there. So augment that 95% that he was predicting. So after passing it, we can now check which are the best parameter. Can you see? So the best parameter is where we have a max depth of none. Then the minimum sample tree is 1, right? Then the minimum sample split is 2. Then the number of estimator is 100 from those parameters that we gave up there.
Uh,
So this parameter is not that I just put it like that and I got it. I had to play around. I try for 10, 15, 20, like that, like that. I keep trying.
okay.
So after passing this parameter, we now still evaluate the best random forest parameter. Go down. So for the tuned one, we still have 95. So that means it will not pass like that. Scroll down. So you can see still after augmenting random forest is not able to pass the 95% prediction.
So what's the importance of the hyperparameter tuning that we did?
The importance of hyperparameter tuning at some point, right? Some parameter might not, even though you get the same percentage, but go
Mm-hmm.
back up. Let me show you something. 94 and 95. You can take the screenshot of the order. So there might be slight changes in terms of other classes, in terms of precision recall and F1 score. It might not really be
Okay.
um accuracy that you only consider.
Mm.
Okay, here
Up
now the
90,
accuracy is 95. Other parameters they will have 94, 94, and
so
and
sometimes it might not be only those things you consider. You have to consider other values. If you can have increase in other values, so it makes sense also.
Okay.
let's go
Yeah,
back. Let me see something quickly. Is it here? Have you done the tuning here?
yeah, that's it.
Okay.
So if you check other values, you might have high tendency that there will be change in terms of even the micro average and stuff.
Oh,
But sometimes you will try and pimp an algorithm, it will not still increase. That means that's the best it can go.
yes.
So anyhow you do, it will not exceed that for the data set. So scroll up.
Okay.
So you
So
can
after the
see,
hyperparameter tuning, you still do
yes,
confusion
to
matrix
check.
again. Okay.
Yes.
Okay. Let's continue. Logistic regression.
So we went ahead to apply logistic regression and we did hyperparameter tuning straight on it.
Okay.
Same thing is with that one. So we have for this one we have 0.90. And these are the parameters that we made the best parameters for it. XGBoost also, in case you don't have it, you run that line to install it or you upgrade it because me, I was having it, I had to upgrade it.
Okay.
So same thing with XGBoost. Go down, you do the same thing, you apply those parameters to it and you tune it. The XGBoost has 94% like that. So next we compare it.
This comparison,
Yeah,
was it based, this one now is 94, was it based on approximation that we got 95 initially?
yes, it will approximate it. Go up a little, you see that I was getting the result up there. Can you see?
Okay.
Accuracy, RF accuracies, comma, accuracy. I did not hard code anything. It's from the accuracy I was getting it straight. So
Okay.
there is being round off like that.
Okay.
Look at where you have accuracies.
Yeah.
Go up a little. First line, look at it there. Accuracies. You can see RF accuracy.
Mm,
If I coded it, you see numbers here, but it was from the results those algorithms gave us that I just put in there.
get
Those numbers.
okay. So please,
So
most
to now
importantly,
calculate.
this one is to save. That one is not a problem, man.
No,
Prof,
this
are
one
you
I
still
just save
are you
from.
still recording?
Yeah, very well.
Okay.
Uh,
So this one is to save the model. That's it.
yes,
You
yes. So
use
me
PPG.
now, where I want us to quickly look at before you go off is this this matrix, this fairness matrix now.
Just go there straight, please, so that I will
Don't
just.
finish now. No plenty again. I think now here
I
we
don't
did now.
talk to them. I don't even tire.
See, sorry. Oh yeah, now this one from here now.
So yeah, you are using most of those things. They are binary stuff. So that's why we are using the binary data set to check how fair it is. So you can see we just from the test instances we just copy the test. Then we also copy the for the label we get the y test, right? Also we join it. Then we also create another column for the prediction, right? Then we also get another column again for the prediction probability. Then from there we'll pass it to our binary level data set from AI fairness metrics. After passing it, we give him the label name, which is label as where the result is stored, so that it can be able to analyze for the privileged group and the unprivileged group. Privileged group here is 1, which is yes, and no privileged group is 0. So after that, scroll down, please. Can you scroll down?
This is where it ends.
Are you with me?
Yes, where should I stop?
This thing is blocking it now. This stop sharing stuff. Can you drag it out?
Yeah, but this is where the code ends.
Look at down of your screen. There is meeting.google is sharing your screen. Can you drag it from there
I've dragged
or
it.
hide it?
I've dragged it. It's your network that is holding it. I've removed it already.
Okay.
Mm.
All right. So for the privileged and unprivileged group, the result there is the you can see the demography parity difference is this. Then the disparity impact is 2.56, 58, something like that. Then for the to evaluate the group based performance, the result also will be down based on those different accuracies. Scroll down. So this is the AUC, right? Based on those fairness metrics, and this is the accuracy, the best accuracy. This is the precision and the recall for the class of 0, and for the class of 1 also look at it. for those two classes that we're trying to predict of churn and not churn. That's the privilege and not privilege group.
Okay. Okay. Do you have a question on this? But to me, I think this session either will,
I didn't get the from here the fairness matrix and all that. Maybe I don't know.
yes, even me too. I didn't get here very well, so I'm just having two thoughts in mind. If we should do our
What are we
personal,
predicting, sir?
no, we are predicting churn, understand,
And not churn.
and not churn, and which we've already predicted up here there. Now,
Good. So you are looking at how fair it is in terms of predicting those two class. Abi?
yes,
Good. So now from that prediction you did, we
mm,
create a data frame to store the predictions.
okay,
Then we also create a label to identify that this is the initial results.
okay,
Can you see white text there? That's the initial answer we hid.
yes, yeah,
Then the next one is the prediction that was done.
yes,
Then the probability of the prediction.
which is this one.
So, good. So we're now telling fairness metrics to evaluate how this thing is fair in terms of the real answers that was there and the predicted answer. Then in the predicted answer, we have two classes, which is the churn and the not churn. One of the class will be the scroll down, the privilege and the non-privilege. Can you see them? So for
Okay,
one of the it, we are looking at the privilege, the unprivileged, which one is privileged, which one is not privileged.
okay,
So a similar value towards each other signifies that the bias is low. So you look at in fairness metrics, you look at the demographic parity and differences and the disparity impact. How how unbiased it is, right?
but
That's the degree.
can we visualize something here to help us understand this more better?
It's just a number now. What can you visualize there again? It's just like accuracy is 0.9 something. Unless you want to compare another different thing.
So this disparity parity now.
Go to
What,
your browser.
oh, you want me to browse this? Even I want to do some work on this one too. So that's what I'm saying. Maybe we can do that one later after the class. What should I
Type
type?
it there. Demography parity fairness metrics. Copy everything to the ending. Apart from that number, Sha, it's not really that important. Paste it there.
The number not really enter, sir.
So
Whether a model predicted are the same across group. It also known as disparate impact statistics.
so how good the model is, how unbiased it is between those two labels, whether it's churn or not. That's what demography parity
Yes, sir.
stuff does.
Okay.
Because the target there is this, then the disparity. You can also look at it, the impact.
No, no problem. Let's not do this. We'll work on it. If there's any question, we'll get back to you.
But you understand the stuff now, right?
Yes.
All right now. Can I ball out any question?
As I said,
For now, we will still need to revisit. Let's
You revisit and the recording.
we'll revisit the recording and we'll do our own research, and if there's anything, we'll get back to you.
for now.
Mm.
Yeah.
I've talked and talked. Oh, my
No,
mouth is even dry like this.
no worry, no worry. Your mouth goes somewhere.
Oga Andrew.
My mouth
He
not
said
dry
his
now.
mouth
Like
is
the talk
dry.
now, they even had me. Like, I have to use all my energy.
No worry.
Abeg, these guys will not keep me.
People when they teach and then they try.
We go buy water for you.
I swear people when they teach, but then they really try because These days, if I just talk one, two like this, I don't tire.
You wey wan enter teaching na dey talk this kind talk.
Brother, that my teaching, if I come class, I no go do 2 minutes, I don't come out.
Student go say this lecturer lazy. He never
The
Ah,
student go
let them
frustrate
talk
to
wetin I wan talk, na dem sabi.
no mind them omo, everything dey work ma don give up oh.
Ah,
The work nothing dey inside jare.
na their job. I no come kill myself. If I enter class, me the way when una dey even teach 1 month, 2 months, una never finish. I dey reason wetin una dey teach dem like that.
Omo,
1 week, 1 week, 2 week, e don do me.
uh-uh.
you know you go just dey John place with that now.
All the outline.
Before,
You will
na
confuse
everything I
all
wan
of them
teach dem.
now.
Like the one wey I dey take software engineering, the material na 180 page with
I go
50.
give dem assignment tire.
Assignment, you need to also understand the assignment you are giving to them.
No, that one is no big deal. I will understand it.
Uh,
I can't give them what I don't know now. It's just the truth. So
Definitely.
that they'll come and be asking me question, I'll just stand blank there.
Omo, no be small thing o. Oya
Now
handle.
waiting I know I go tell them, the one where I don't know, I go tell them straight. I no sabi. You
No,
guys should go and
you dey good for practical. Anybody wey dey good for practical, if you go class, e no dey hard you.
now that lengthy talk, now they give me headache now.
How you go do now? Before you go know, 2 hours go pass.
Omo,
No, no. If
this
really
one
you
what we don't do
understand
like
it
this.
before you and break it down to pass the knowledge to others, you won't even know when the time will. You won't know that you have spoken for 3 hours. Seriously.
Yes, it's like that too. It's like
I
that.
beg, you be like say you do something for there. Hold on. That place where your cursor they blink.
No, I no do
Remove
anything
am.
o.
Okay, yeah, you no do anything.
No worry, no be this one. I no even run this one. I go Jupyter notebook run the code. I no dey run code
Alright,
for this one. I no dey understand this idea.
it's fine, no problem.
Oh, I still dey leave record in the top.